calculate the appropriate amount of medication given specific information. So we are going to use dimensional analysis and identity ratios to do this, thinking through, the pounds to kilogram, in that there's more than one way to do this. So depending on what you use, you might get answers that are slightly different, but we're looking for like basics. All right, so let's think through this. A patient weighs 168 pounds and needs medication with dosage instructions of 25 milligrams per kilogram per day. The medication is to be given 3 times a day in equal dosages. How much should the patient receive per dose? Round to the nearest whole numbers. Now, you're looking at this and maybe you're going, exactly. What we know is that this patient is getting 25 milligrams of the medication per 1 kilogram of weight. Well, right here we see a discrepancy because kilogram of weight, pounds are not the same. So, to do our calculation, we always start with the weight of the patient. So if my patient weighs 168 pounds, I need to change pounds to kilograms. Now, because we are, as I say, jumping across the pond, going from U.S. measurements to metric, there are 2 different conversions. You could use identity ratios, and you should get the same answer when you round to the nearest whole number, no matter which one. But I like to use 1 kilogram is the same as 2.2 pounds. Now, you'll notice I put 2.2 pounds in the denominator because I need my labels to reduce from numerator to denominator. So they have to be the same unit, top and bottom, so that they cancel out. Because now you'll see I am in the label of kilograms. That's great. So this right here, 168 times 1 over 2.2, will allow me to find the weight of my patient in kilograms. But that's not exactly what I want, right? I want to know the dosage. How much should this patient be getting? So this is where we use our medication dosage. I know the patient should be getting 25 milligrams per 1 kilogram of weight. Now that right there says, okay, that means my kilograms go away. That means I am no longer mathematically in the weight of my patient. I'm now in the milligrams that my patient is receiving. So this will give me the total milligrams. So to do that, I start with 168. Because 2.2 is in the denominator, that means I'm dividing by 2.2. And 25 is in the numerator, so I'm going to multiply by 25. So if I take 168 divided by 2.2 times 25, I end up with 1,909.09. It keeps going. This is total milligrams per day. That's great and all, but the question says, hey, if they get the medication 3 times a day in equal dosages, how much should they get? So that means we're going to take the total dosage, keep that in your calculator, and divide it by 3, because 3 equal dosages. So that'll give me 363.36, continues on, milligrams per dose. And if it says round to the nearest whole number, 3 tells me to round down. So total, 336 milligrams per dose. So you've got to really understand what the question is asking before you put all the pieces together. Let's do another one. A doctor orders 2.5 grams of medication to be given. The medication has a concentration of 60 milligrams per milliliter. How many milliliters should be administered? Okay, so there's a couple ways you can do this. The big one is saying, well, okay, I know that I have, right, this is what I need. I need 2.5 grams of medication, but 60 milligrams per milliliter, that means I really need milligrams. Well, how do I go from grams to milligrams? You can do this 2 different ways. One, you can do the counting method, right? Because if you think like grams, then we have deci, and then we have centa, and then we have milli. So we're going to move it right 3 places. Or you can say there are 1,000 milligrams in 1 gram, which allows my units. And so I would have 2,500 milligrams. All right, same idea. That's this piece by moving it 3 places. Okay, so get a new problem here. I know that I have, my doctor is ordering 2,500 milligrams of this medication. Well, if the concentration is 60 milligrams per milliliter, Why did I put 60 on the bottom? Well, think about your labels. If I need to reduce, right, I need my milligrams to go away. So numerator to denominator, I can reduce, right, I can simplify, and now my label is milligrams. And if there's no value, it's just a 1. So I'm going to take 2,500 divided by 60, and that's going to give me 41.666, keeps going, milliliter. And let's go ahead and round 6 rounds up. So that's 42 milliliters. And that's it.